Okay, let's dive right into this explainer. Today, we are looking at a massive, fundamental shift in how we create, invent, and build. I mean, think about it. For generations, the whole act of making something new was completely changed to a physical workbench, right? You needed the right tools, raw materials, and a ton of space. But modern design, it's leaving that physical workbench in the dust. We're stepping into an era where the stubborn constraints of the real world just don't dictate the speed of your imagination anymore. So we're going to talk about why virtual tinkering doesn't just replicate the physical design process, it absolutely beats it.
I really want you to let this quote sink in for a second. Creation has slipped the grip of the physical room. Wow, right? It's highly evocative, and it perfectly sets the stage for the massive shift we're analyzing today. The workshop isn't defined by a dusty parts bin or the four walls of a garage anymore. It's expanding across our screens into shared 3D canvases and these wild digital spaces.
Which brings us to a really fascinating question. What actually happens when the workshop no longer needs four walls? Seriously, when you aren't restricted by what you can physically grab or what you can afford to break, how does that change the way you invent? Let's take a journey together from the restrictive, heavy physical world we all know straight into a boundless digital future.
Section 1. The old reality, limits of physical workshops.
To really get where we're going, we've got to understand the baseline, the gritty friction of traditional physical trial and error. You know the feeling, the solder scars on your hands, the sad pile of wasted parts, that very distinct smell of heated acrylic. Real workshops definitely teach through this friction, but man, that friction has a steep cost. When you burn a trace or print a housing with the wrong tolerance or crack a mold, you aren't just losing materials. You're bleeding time, you're bleeding money, and worst of all, momentum. The sheer fear of these physical mistakes often forces creators to make safe compromises instead of taking those bold, crazy risks.
Section 2. The digital shift. Enter the innovation sandbox. So what if you could just remove those heavy physical costs entirely? Let's define exactly what we mean here. Virtual tinkering is a boundless digital workshop where art, engineering, code, simulation, and play all collide for ultra-fast iteration without any physical waste. So the crucial point is that this isn't just some sterile 3D model viewer or a flat, boring design tool. No, it's a living, breathing environment built specifically for motion, risk, curiosity, and remixing. In this space, the beautiful mess of making totally survives, but the limits fundamentally change. An idea can be sketched out, tested for extreme stress, torn completely apart, and rebuilt into a brand new shape. And get this, you can do all of that without wasting a single sheet of metal or 1 inch of 3D printer filament. You get to keep the creative chaos, but you completely lose the physical penalty.
Section 3. Fast, safe, useful failure.
Now, what's really interesting about this comparison is the stark contrast between these two environments. Look at traditional workshop pressure on one side. It absolutely forces you to deal with material waste, ridiculously long setup times, real safety limits, and relying on local access to tools. But then you have virtual tinkering pressure, which completely liberates you. You get fast resets. Your failed models are just data, not expensive debris sitting in a trash can. You can simulate stress without blowing anything up, and you have networked access to collaborate from literally anywhere. The heavy costs of physical mistakes just vanish, replaced by the total freedom of digital trial and error. And because a bad enclosure doesn't mean sitting through another agonizingly long print queue, the whole rhythm of prototyping accelerates dramatically. Make, test, break, rebuild, repeat. You can overload a massive lighting installation until it literally collapses in a simulation, and then just hit reset. When making failure becomes this fast and this safe, creators are encouraged to take much, much bigger swings. The fear of waste just no longer stands at the door like a guard. Section 4. The living digital workbench. Just imagine the vivid sensory contrast between a static physical bench and this highly dynamic digital workspace. You step into a space where the surface literally reshapes itself around your work. One second, it's a circuit layout bench with floating signal paths. The very next, it's a product design bay with exploded mechanical assemblies just hovering there in the air. Then boom, it transforms into a sculpture platform. It doesn't force your project into a rigid grid, it actually molds itself to the thing being made. Because the workbench is this adaptable, it paves the way for a sheer diversity in cross-disciplinary ideas. Visual, mechanical, and electronic thinking can finally share the exact same space. I mean, look at these exciting hybrid projects enabled by this tech. We've got sculptures that respond to body movement, wearables that behave like musical instruments, furniture that actively senses your posture and changes form.
You also see public art reacting to real-time weather data, toys that teach mechanical logic, and interfaces that turn sound directly into physical motion. These projects just don't fit neatly into one traditional toolset, but in a virtual tinkering lab, they absolutely thrive. This level of integration means prototyping turns into a literal performance of thought. Because of real-time collaboration, you can have a coder attaching behavior to an object, a sound designer testing reactive audio, and a fabricator flagging an impossible joint, all at the exact same time. The chaotic, beautiful process of iteration becomes completely visible and totally honest. Every single version tells a story, and the workspace preserves every branch, every dead end, and every major breakthrough.
Section 5. Democratizing maker culture.
Beyond the incredible technical capabilities, there is a profound societal impact here. Maker culture expands when the door gets lighter. Let's be real, physical workshops inherently require money, space, and expensive tools. That means access has never been equal. But virtual tinkering changes the starting line. If the first crucial stage of making happens in a shared digital environment, well, anyone with an idea can begin. Let's see how this builds an entirely new field of creators. We are seeing students prototyping complex modular assistive devices before ever touching expensive fabrication equipment. We see musicians designing wild new controllers without needing to own a CNC machine, game designers testing physical toy mechanics, and fashion makers simulating intricate wearable structures. This democratizes invention by empowering bedroom producers, disabled creators, and students to innovate purely on their merit of their ideas, without ever needing permission from a traditional gatekeeper. Section 6. The physical-digital loop. As we wrap up our core argument, it's vital to understand we aren't abandoning the physical world. And this brilliantly illustrates the ultimate future of the workshop: physical to digital, digital to physical, and back again. The digital sandbox simply ensures that only the absolute best, battle-tested ideas earn their physical, real-world form. A broken physical object can be scanned right back into the digital space to solve a design problem, then printed again as a perfect prototype. Real materials, gravity, heat, and human touch, they still matter deeply. But the digital lab ensures you arrive at that physical stage with much sharper questions and infinitely better forms.
Creativity no longer needs to wait for permission from matter. Matter can join later. The idea starts now. The future workshop will highly reward those who move fluidly between disciplines without fear. Creators who test impossible shapes and misbehaving mechanics in the digital realm before committing a single physical resource.
So, having seen how this completely shatters the limits of the traditional workbench, I'm going to leave you with this final provocative thought. What is the very first thing you're building in the virtual tinkering lab? The sandbox is open, and it's time to let your ideas run wild. Thanks so much for joining me on this explainer. Keep learning, keep experimenting, and I'll catch you next time.